What's going on, everybody? So my name is Bryce and today I'll be presenting the compiler project I've been working on for the past few weeks of this course. I've been working on a tiny C interpreter, which is built in Python using the Ply library. I also designed an AST-based interpreter, meaning that the code is parsed into an AST before execution. Along with Ply, I use supporting classes like stack and symbol table to manage variables and expressions. My main goal for this project was just to better understand how compilers work and to be able to get an understanding for building one and how certain features like grammars and tokenizations work. Also, I just wanted to push myself to learn something that I've never worked with before, and I feel like this project was perfect for that engagement. So for my project overview, my interpret process is simple C-style source code. Source code is passed from a source file in which it will be interpreted. It can handle basic arithmetic expressions, things like if and else statements, while and for loops, trig functions, input-output, and variable assignments. Ply is used to handle the tokenizing and parsing phases of the interpreter, and I was able to use Ply's Yak module to write the grammar rules and describe the syntax of my tiny C language, which allowed me to structure the coding how I wanted. Each of the grammar rules create a separate AST node instead of directly executing them, which can be useful for saving things in memory to execute later on. The structure of the interpreter is in two major phases, the parsing and executing, or the compiler and interpreter classes. The source code is tokenized first and parsed into a Ply, using Ply into an AST, and the nodes are created. Each of these nodes in the AST represent a part of the program, like a statement, an expression, or a control flow structure. Then the interpreter actually walks through the AST and executes it. Some of the challenges faced, I think the biggest challenge that I faced was properly building and managing the AST itself. Initially, some of the nodes weren't recognized correctly during the interpretation, which led to confusing errors. Another difficulty was just handling the input, output, especially like distinguishing between strings, numbers, single characters, adding minuses in or negatives in my scanf to allow negative like -1 to quit. Debugging was also difficult at times where sometimes things would just go wrong and I had no clue what it was. I also experienced ambiguity in my grammar that would cause things like shift and reduce errors, which necessarily didn't mess up my code, but were things that Professor Wilburn obviously didn't want. Some of the results and outcomes of my project were by the end of the project, everything successfully worked. I met the core requirements of everything. Some of the features that I'm proud of were the loops, the for loops that I did for extra credit. Um, Through this project, I developed just a much deeper understanding of parsing and interpreter design and the practical challenges involved. One surprise was just how tricky even simple looking control structures could be. I think something that was surprising to me was how similarly some of the commands could be using like I use while loops to implement my if statements and stuff like that. Again, this project was just very useful for continuing to grow my skills of writing code and thinking about different issues and how to solve them. So for future applications, I think in the future I would just love to continue working on this tiny C interpreter so that the language is almost exactly how the C language is, because as of right now, it's still only a very tiny version of C and does not have all the capabilities. I was able to learn a lot while working on this project, especially more about ASTs and the C language itself, and even building an interpreter and compiler. I think these skills that I learned are applicable to many areas in software development or language design. Overall, I just really enjoyed this project, and I'm glad that we had the time that we had to continually work on and deeply focus on this project and get the best understanding. So here you can see if we put in a source code, it's long, it executes, and the code actually works. Gets the correct number, 40 too low, well, 45 too high, 42 just right. Congratulations. Oh, and by the way, if you're curious, your number squared is 1,764. So this just goes to show that my code does work. It's executed from the source file up here into my actual code. I just want to give a big shout out to everybody. Thanks you all for listening, and thank you to everybody who helped me along this journey. Shout out to Dr. Wilburn, and special shout out to Brianna because I know we talked a lot throughout this project.